Hello everyone. This video we are covering nonlinear systems of equations and inequalities. Section 10.8. We have three examples. I think we might need two videos for this section. Let's look at example 1. Solve the real solutions by graphing and algebraically. So here, real solutions means we are solving the system in real number set. We don't worry about the non-real complex solutions. In this system, we have two equations. If you look at equation 2, x minus y equals 2, that is a linear equation, right? You know that's a straight line. X minus y equals 2. Negative y equals negative x plus 2. Divide both sides by negative 1, y equals x minus 2. So that is a straight line with the slope 1 and the y-intercept 0, negative 2. However, if we look at the equation 1, that's not a linear. If we look at the equation 1, it is x minus 2 to the power of 2 plus y equals 2. If we isolate y by itself on the left, we have a y equals negative x minus 2 to the power of 2 plus 2. What is this? Of course, if you FOIL, you would have a quadratic function here. But we don't have to because the form of the function is even better for us to solve the system, because this function is a quadratic function in the vertex form. Do you guys remember that? Vertex form. Yes, the graph of the quadratic function is a parabola. The vertex actually is 2, 2. So do you see that? So that's the reason the system is nonlinear. The system is nonlinear because one of the equation is not linear. It is quadratic. Okay. Let's see how do we solve this system. Let's look at the first equation. We are going to graph the equation. Okay, we are going to graph it. In order to graph it, we could rewrite that function in the vertex form as I did it earlier. Y equals negative x minus 2 to the power of 2 plus 2. From this function, which is in the vertex form, I want you to tell me the leading coefficient A and the vertex h, k. If you want, you can refer to the previous sections for this content. The leading coefficient A is a negative 1. It's a negative, so the parabola is opens downward. H, k is easy to find. If we get rid of this part, y reaches its maximum. You know, if the parabola opens downwards, it has maximum, right? It has a maximum value. The maximum value would be 2. If this part be 0, this part is non-negative because it's the opposite of a perfect square. So that part definitely is less than or equal to 0. At most is 0. So y at most is 2. So the maximum value of y is 2. That's the value for k. If you want a y be 2, then this yellow part has to be 0. In order for the yellow part to be 0, the base x minus 2 has to be 0. You want x minus 2, the base be 0, so you have x equals 2. So that's how do we find the h. That's the vertex. Let's graph it. Of course, if we want to graph the parabola even better, we want x-intercept, right? And a y-intercept. So we let y be 0. Then we have x minus 2 to the power of 2. plus 0, that is 0, equals 2. So we have x minus 2 to the power of 2 equals 2. X minus 2 equals plus or minus square root of 2, which is about 1.414, and x equals 2 plus or minus root 2. That is a square root property, right? So the two x-intercepts of the problem is 2 plus root 2 comma 0 and 2 minus root 2 comma 0. This number is about 3.414. This number is about 0.5. Yeah, between 0 and 1. Okay, you don't have to be that accurate. You just need to find the location for the two intercepts. If we let x be 0, then we could find the y-intercept. We let x be 0. The function is x minus 2 to the power 2 plus y equals 2. If we let x be 0, 0 minus 2 to the power 2 plus y equals 2. Negative 2 to the power of 4. 4 plus y equals 2. Y equals negative 2. So the y-intercept is 0, negative 2. All right, I think we are ready to graph the parabola. Vertex. Where's the vertex? This is the vertex. X-intercepts. Y-intercept. So let's find the location for them. 2, 2. Here. Remember, this is about 3.4. It's going to be here. This is about a 0.5. 1.4. 0.6. Something like that. So it's about here. 0, negative 2. This is negative 1. This is negative 2. It's a parabola opens down. So you can see the parabola. It's gonna be look like this. Right? That's a pretty nice one. Okay, so that's the graph of the equation 1. The graph of the equation 1 is a parabola. All the points on the parabola are solutions of equation 1. How many points do we have on a parabola? Infinitely many, uncountably many, right? So equation 1 has a solution set including all the points. Those are ordered number pairs. Equation 1 has a solution set including all the points on the parabola. For equation 2, let's see what's the solution set of equation 2. As we explained, equation 2, x minus y equals 2, is a straight line. It is y equals x minus 2. Slope is 1. Y-intercept is negative 0, negative 2. 0, negative 2. And the slope, well, it happened to be the same with the y-intercept of the parabola, right? And the slope is 1. 1 could be, slope we use m. 1 over 1 or 2 over 2, right? Okay, so let's locate the, let me change the color. How about let me use the, what color? I think the purple is fine, but yeah, it's like a crime. So this is the y-intercept. We go up 1, go to the right 1, we get another point. We can keep doing that until we have a nice number of points, and we can draw a very nice straight line. Alright? How many points on the straight line? Infinitely many, uncountably many. Those points on the straight line, they are the solutions of the equation 2. Let me repeat it. All the points on the parabola, they are the solutions of equation 1. All the points on the straight line, they are solutions of equation 2. We are solving the system. A solution, if an ordered number pair is a solution of the system, then the ordered number pair is supposed to satisfy both. Then we are looking for the intersections of the two graphs. How many intersections do we have? Yeah, we have 2, right? So this one is obviously 0, -2. They both have the same y-intercept. And then the other is this one. How do we find that? How do we find the coordinates for that point? Because that's a solution. Yeah, how do we find the coordinates for that point? That's a solution of the system. Then we would have to solve the system. You see the title, the requirement, solve the real solutions by graphing and algebraically. So we are going to apply the algebraic method to find the coordinates of the other solution. Let me copy the system one more time. X minus 2 to the power of 2 plus y equals 2. And this one is x minus y equals 2. This is equation 1, this is equation 2. Algebraic method to solve system, including substitution method, also including addition method. We talked about those two methods before. This is pretty convenient to apply addition method because if you look at the coefficient of y in equation 1, it is a positive 1. The coefficient of y in equation 2 is a negative 1. So if we add them up, y would be cancelled. Then we have x minus 2 to the power of 2 plus x equals 4. 2 plus 2 is 4, right? And then let's solve this equation. If we FOIL, I'm going to leave this for yourself, okay? X minus 2 to the power of 2 gives us a quadratic trinomial. X squared minus 4x plus 4 plus x equals 4. Everything goes to the left. Oh, by the way, hold on. Before that, you see 4 on the left, 4 on the right. Could we just get rid of it? Yeah, then we would have x squared minus 4x plus x equals 0. Combine like terms, x squared minus 3x equals 0. Factor x out, x minus 3 equals 0. So x equals 0 or x equals 3. As x equals 0, y equals, because y equals x minus 2, right? So y value is 2 less than the value of x. Y would be negative 2. You subtract 2 from 0, and the corresponding y for x equals 3 would be 1. Okay, so 0 comma negative 2, we have it already here. And the other one, 3 comma 1. 3, 1, 2, 3 comma 1. So my graph is pretty accurate. 3 comma 1. So that's how do we find the solution set of the system. If you need to make a conclusion, the solution set, you can write those words down. The solution set of the system is a set containing two solutions. The first one is 0 comma negative 2. The second one is 3 comma 1. That's the solution set of the original system. It's nonlinear, but the way that we solve it is pretty much the same with solving a system of linear equations. Example 2 is a word problem. The product of two positive integers. This is very important information. So we are not considering 0, we are not considering negative integers. Is 144, and their sum is 25. And what are the two integers. That's a pretty simple application problem. The goal is to find the two integers, right? Let x, y be the two positive integers. Then we have two variables. We need two equations in order to solve for the two unknown variables, right? By the information in the problem, their product is 144. So x times y is 144. Their sum is 25. X plus y is 25. So we are looking at a system. Equation 1, equation 2. Equation 2 obviously is linear, is a straight line. Equation 1 is a hyperbola. Anyway, it's not linear, it's nonlinear because the power of this term is 2. Power here we have a 1, we have a 1, 1 plus 1, we have 2. So the first equation even is pretty simple, but it's not linear. So this is another nonlinear system application. Let's see how do we solve it. We are not going to graph. We are not going to graph in this case. We'll just apply the algebraic method to solve for the system. If you want to graph it, you would see something like this, okay? The graph of the hyperbola, because both x and y are positive, it is a curve like that, decreasing curve like that. And x plus y equals 25. As x equals, and this number is 12, 12. X plus y equals 25. Where is 25? 25, this is 12, this is 24. 25 is about here. So you can see that if you have a graphing calculator, that might be better. It crossed twice, by the way. Mine is not very accurate, especially as the 25 is only 1 unit more than 24 here. So they cross twice, okay? By the way, they cross twice. Yeah, you could use a graphing calculator to assist you. You would see that the graphs of the two equations cross twice. So you're expecting to have two solutions. But as I mentioned, we are going to solve it just by using algebraic method. This time we are going to apply substitution method. How about that? From equation 2, I could rewrite y in terms of x. Move x over, 25 minus x. I label this as equation 3. Plug equation 3 into equation 1. Equation 1 is x times y equals 144. We copy x. We are eliminating y. We are getting rid of y. So we copy x. We copy everything except y. We copy everything except y. Instead of copying y, we are going to put 25 minus x in place of y. Now look at this equation. You have no y. Y is eliminated. That's the key idea or the point of the substitution method. In the new equation, we only have x. Let's solve the equation for x. Distribute x times 25, 25x. X times negative x squared equals 144. Everything goes to the right. X squared minus 25x plus 144. And switch the sides because we get used to have 0 on the right hand side and the function the function on the left. And 25x plus 144 equals 0. Right hand side is 0, left hand side is a quadratic trinomial, so that is a quadratic equation. Remember our method, slide. Well, okay, hold on. We actually don't need a slide because leading coefficient is 1. Shortcut method, let's try. Let's try to FOIL. Sorry, let's try to factor. Let's try to factor by using my shortcut method. Factor the trinomial on the left. We need to find the two integers whose product is 144, whose sum is negative 25. So are those two numbers must be both negative though? Yes. They must have the same sign. If they are both positive, then the sum gonna be positive. However, we have the sum negative, then the two numbers must be both negative. For 144, we have many different options. We can write 144 as 1 times 144, 2 times 72, 3 times 48, double check. Yes. 4 times 4 doesn't work. 5, no, 6. Yes. 6 times 24. Let me double check. Yeah. 7 doesn't work. 8. 8. Let's try. 18. 18 times 8. Yeah. So if you don't remember the shortcut method, this is a chance for you to recall the content. What about 9? 9 times 1, 6, 16. Right? Double check. Yeah. What about 10? 10 doesn't work. 11, no. 12 times 12. Yeah, we know that. Okay, so that's all the possibilities. That's all the possibilities. We need both of them are negative, right? Which two negative number add up to negative 25? Only one. This one. You can see other options. It don't work. So the two numbers are negative 9, negative 16. So by the zero product property, we have x equals positive 9 or x equals positive 16. Because x and y add up to 25, that is given. That is equivalent to, right? Because x and y add up to 25, we would have, if x equals 9, y would be 16, because they have to add up to 25. If x equals 16, y would have to be 9. By solving, if we only look at the solution of the system, it does have two solutions. The two solutions are 9, 16 and 16, 9. Again, if you use the programming graphing calculator, you would see the two intersections of the hyperbola and the straight line. However, this is a word problem, right? We're looking for two integers. The two integers could be 9 and 16 or 16 and 9. They mean the same thing. Do you see what I'm saying? So yes, we have the two integers are 16 and 9 or 9 and 16, really the same. So the two positive integers are 9 and 16. Okay? Is that clear? Let me move this part. Okay, let me see how many minutes. I think I want to stop here and start a new video. Okay. I'll explain example 3 in the next video.